All right, who remembers the three-part definition of continuity from last class? What was the first one? Amelia.
That option has to be defined.
Yes. So we said like f of a is defined, right? What was the next part?
Exists.
What exists?
F of A.
No, that was the first one. Second one is the limit as x approaches a of f of x exists, meaning that it has to exist from both sides, right? You don't have to do that, but like left and right would have to exist. And our very last point, back table. One of you boys are per twos. Nobody remembers. Pay more attention, guys. It means that these two things need to be equal. F of a has to equal the limit as x approaches a of f of x. That's our three-part definition. Y'all remember it now? I mean, we used it like all across. Who just said yes, sir? That was so nice. Look at that. I like that. Nah, that's okay. You don't have to do it. All right. Let's do it. Going to learn about IVT, Intermediate Value Theorem. All right, we're going to write a gross definition, and then we're going to like put it in layman's terms for you, all right? So let's start with our mathematical technical version first, which means Sophia's going to pay better attention, right? So if f is continuous on the closed interval a comma b, and k is any number between f of a and f of b, in other words, the y values, there is at least one number c in AB such that f of c equals k. I'll let you write that down, and then we'll put that into simpler terms. But that's our mathematical definition. I promise I have an easier way to explain it once you're done writing it down. Promise. Yeah.
And he started trying to explain to me what the derivative was, and I was like, stop.
Aren't you writing the test? Aren't you doing the College Board test?
He wants me to do it, but I'm scared that I'll do it and I'll fail it, and universities are going to see it.
But just don't show them the test.
They're...
Just show them your course grade.
But I might do it. Even if it's just
Anyway, if you do it,
final grade.
the thing is, you got to learn limits before we do derivatives. Because that's what they want. But yes, the derivative is what we're going to spend more time on, for sure.
The derivative and the
Integral.
Yeah.
The area under a curve. It's the whole reason calculus was invented. To find the area under a curve. That's where we're getting at the end. All right, you guys ready for like the simpler definition of this now?
Yes.
Yeah?
Still writing.
Well, that's because you were talking.
But I was talking about. I didn't understand.
That's okay, we're going to figure it out. All right, so why don't we, since Amelia didn't understand, we're going to use her as our guinea pig. Amelia, how tall are you?
Like in meters.
Sure. 107? 107?
70.
170. Okay, 170. How tall were you 3 years ago, roughly?
Like 120 or 30.
130? Sure. So right now,
No, like 150.
okay. All right, 150. So here's what we're going to do. How old are you right now, Amelia? Oh my God, she doesn't want to listen.
No, sorry.
How old are you right now?
16.
She's 16, and she's 170 centimeters. You used to be 13, and you were, take a guess, what did you say, 130?
165.
You've only grown 5 centimeters?
There's no way that she's grown more than 5 centimeters. Because I'm a girl. Girls stop growing after that.
All right, fine. We'll say she was 165. I'm not sure I believe
I
it.
don't know.
It's okay. It doesn't matter. It's not that big a deal. Guys, this here, these are my A-B points. Okay? Technically, like, this is A, this is B. This is F of A. This is F of B. What I'm saying is that some number C, such that C is in between A and B, or really f of c is in between it, it's going to exist. So let's talk about this more simply. If Amelia was 165 centimeters 3 years ago, and she's 170 centimeters today, was she every single possible division in between 165 and 170 at some point in her life? Yes. Right? So basically all this means is that if the 2 points exist and it's continuous data, then everything in between it exists. Does that make sense?
Okay.
Right? She didn't like skip 168 centimeters. She was exactly 168 centimeters, even if it was only for a day. Right? Because she grew in between there. Does that make sense? Good? All right. So that's what intermediate value theorem means. It just is that if it's continuous data, everything between the 2 points exists. Then it's not continuous. That's why we used your height, because your height is continuous data, right? Anything that's continuous, this will be true for.
Why do they say at least one number? What do you mean like?
Well, it could be more than one. So the height, let's pretend that Amelia is now 94. We're in the future. She's 94. Maybe now at 94, she's 162 centimeters because, you know, she got old and shrank a little bit, right? So maybe now there's 2 different times in her life where she was 168. So that's why we're saying there's at least one, but it doesn't mean there isn't more than one. There could be more than one. Basically, the data could go like this, and if this is the point we're looking at, there could be a whole bunch of truths. But we know that for sure there's at least one. Okay? That's what we're saying. Are you good now, Amelia? Excellent. All right, so let's put this into some practice here and see if we can use IVT to do some proofs and know that things are true. All right, so we're going to look at these 2 graphs below, which are just piecewise functions. We're also given the functions here. Is there a value of c, so some value in between here, on -5 and 2? So let's start by actually like closing in what we're looking at. So we're looking at -5 and 2. So we're looking between there, such that f of c equals 2. So is there some point where this will be equal to exactly 2? Yes, there is. Right? It's right here. Right? So yes, there is. And it's at like roughly, I don't know, let's call that like negative 4.5 roughly. I don't know.
Like, how do you know how much to...
Well, I know it's 2 because I can see that the graph here goes through that point of 2. Like y equals 2, right? So I know it exists. It's there.
It's not 0.
What do you mean, why is it not 0? Because it's 2, man. I don't understand your question, I think. Sorry, I didn't mean to make you feel bad. I just think I don't understand your question. Okay, let's continue though, okay? Does the IVT guarantee a value of c such that f of c equals 2 on the interval -5, 2? What do you guys think? We know it exists, but does IVT guarantee it?
Yeah. No,
That's the one about your height.
intermediate value theorem.
Yeah. Does the intermediate value theorem guarantee that that point there that we just found that we can look at, does it guarantee it exists?
No,
No, why?
it's not continuous.
It's not continuous data. We got this big hole right here, right? So down here, that's exactly what we're going to say. We're going to say no, f of x is not continuous on the interval -5 and 2, right? Now I get it. You might be like, dude, we just looked at the graph. That's great. But again, I'm not always going to give you the graph, right? So that's kind of the whole point here, is that we use the graph as a bit of a crutch from pre-calc, but the whole point of this is we're learning how to do all these things without a graph so that we don't always need to graph it. We can analyze it without it. And if we do have a graph, well, it still lets us just prove things. It's good for proofs. All right, so now we're going to look at the next one. So now we're looking between -1 and 5. Exact same graph. Now, is there a point there that it's going to equal 2? So up here. Nope. All right, does the IVT guarantee a value of c such that f of c equals 2 on the interval? Blah, 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 blah. Now, in this case, the answer is no, because 2 is not between my endpoints. And my endpoints are going to be f of negative 1. Actually, you know what? Let's write it out the full way. F of A and f of B. But let's write out what those things are. So f of A is really f of negative 1. F of negative 1 is like roughly negative 0.5, it looks like. And f of B over here, we don't actually have it, but that's going to be f of 5, which looks like if we extend this, it's going to be roughly, what is that, 1, 2, 3, roughly negative 3.5, roughly. So the point is, 2 doesn't lie between those. Would you agree? Like 2 is not between negative 3.5 and negative 0.5. So IVT tells us nothing. Nothing we can do. Oh well. Let's continue, shall we? What 2 conditions, therefore, need to be true in order to make IVT applicable? Yes?
The value needs to be between the 2 limits.
Good?
And the interval needs to be continuous.
Good. So let's start with that one. F has to be continuous. Okay, so if it's not continuous, we can't apply IVT at all. It could still be true, right? Like in our first example, it was true, but we can't prove it using IVT. All right, and then the second part there was that K must be between, remember K was just a fancy parameter for Y. So K must be between the f of X or Y values of the interval's endpoints. So in other words, it needs to be between the y points of the endpoints. So like for our age example, Amelia was 165 and 170. Those are our y values of our endpoints from 13 to 16 years. Okay? Does that make sense to everybody? I'm going to take your stunned silence as absolutely. Total, exactly. All right. I know you're making fun of me. It's okay. Let's put this into practice now when we don't have a graph. Okay, because like I said, a lot of time we don't have a graph. And if you don't have a graph, sometimes it's faster to do this. And even if it isn't, again, it still just lets us prove some things. Okay. So right here, we've got this function, a rational function. We've got the interval from -1 to 3. And we want to know if there's such a value as 2/3 on there. Does it exist somewhere? Okay. Well, the first thing and the easiest thing that we can look at is actually where this thing's going to have a hole. But for the sake of being thorough, let's do the whole thing in order. So, no, actually, let's start there. Let's start there. That's easier because the first thing was to be continuous. So where is this graph going to be discontinuous? -2. Perfect. Is -2 on that interval? No. No, so we're okay. All right. So it is continuous so far. So then let's check our endpoints. So f of -1 is going to be -1 minus 3 over -1 plus 2, which is really -4 over 1 or just -4. Then we need to check the other endpoint, so f of 3, and that's going to be 3 minus 3 over 3 plus 2, which is 0 over 5, which is just 0. Okay? Now, does 2/3 lie between -4 and 0? No, right? So no IVT. 2/3 is not between -4 and 0. There's nothing we can do. No IVT. Could still be true, but IVT doesn't prove anything. All right.
Can you wait 1 second?
Yes, I can. Sorry, I write too fast. I write too fast for y'all. Are you okay now, Amelia? Yes. All right, so we have the exact same equation, and where was it discontinuous?
-2.
Right, so it's discontinuous at x equals -2. And does -2 lie on our interval this time?
Yes.
Yes, so therefore right off the bat, no IVT, and our reason is, all right, so f of x is not continuous on our interval from -4 to 1. It has a problem at -2. Oops. For twos, how you doing? Good? Excellent. Yeah, so it's because like on the bottom here, like if I put in -2, it becomes 0, and I can't divide by 0. So therefore, -2 is on that interval, so it doesn't work. All right, let's try a third one. We get to do some trig, because I know how much y'all love trig. I love trig. Well, that's sad for you. All right. So we're looking at this. Is there anywhere that an exponential function will be undefined? No. Is there anywhere that the cos function or a trigonometric function will be undefined? Nope. Therefore, this thing exists everywhere. The domain of this is ER, right? So x is an element of the reals. Therefore, we have no problems. So we can go ahead and apply it. It is going to be continuous because it is continuous everywhere. XER. X is an element of the reals. So this one is continuous everywhere. Guys, if you don't remember what XER is, you need to come see me later, okay? This is not the class for that. You've been doing that for years.
The if means like belongs to, right?
Exactly. Exactly. All right, so we're going to find P of -2 first. So that's going to be e to the -2 plus 2 times the cosine of -2. Then we're going to find the P of 1, which is e to the 1 plus 2 cosine of 1. Now, I can't do either of those in my head. Good, I'm not that good. So, let's have boys do the top one, girls do the bottom one. Shall we? Use your calculator. Let's see how good you guys are. Close. And then you got to multiply by cosine -2. You're on the right track. You're on the right track. Yes. Ln of 1 is 0. Ln of 1 is 0. In this case, you need to just use your calculator. It's not. This one's not on the unit circle. All right, boys. Who's got it? Anybody got it yet, boys? Jack, you got it? All right, the girls got it? 10.85 for the girls. That's correct. Let's go 852 just for fun. Why? Why am I doing that, guys? Honestly, because the College Board loves to do 3 decimal places. So that's why I tend to do it. They don't use significant digits usually. They use 3 decimals. So that's what we're going to do. I know I prefer sig figs, but College Board doesn't. At least not usually. Boys, who's got it? Girls that are way faster than you boys. And you had the easy one. You had the easy one, boys. Because what's e to the 0? 1. So it's literally just cos -2. What's taking so long?
-0.416.
Good. All right. So does 5 lie between those two things? Yes, IVT will work. So now what we're going to do is let's take it a step further and let's find it. Okay? So now we know that 5 has to be equal to this, where we have e to the c plus 2 of cosine of c. Now, you're like, great, Mr. Brad, that's awesome. That does not tell me anything. It does, because you could graph that. So what we can do is we can graph that. So let's see here. Let's open up Desmos. So we were going to graph 5 and e to the power of x plus 2 times the cosine of x. And I want to know where those two things intersect, except here, exactly like this. You're going to graph it, and you're going to find the intersections. Well, in Desmos or on here, I don't care which way you do it.
In college board, we can, like the exam, we can use that.
You can use a graphing calculator for parts of it, yeah. Yeah, absolutely. So like this would be definitely, this is a question where you'd get to. All right, so we've got a few different answers here. Which one would be the one that we want, do you think?
The interval.
The one on the interval. So my interval, if you remember, was, I think it was -2 and 1. So it has to be between there, meaning that's the answer that I want. Does that make sense? Yes? No? Maybe so? Anyway. So -0.333, etc. Alrighty. I can't get the thing I want now. Move that over. There we go. And so in this particular case, C was -0.333, I forget. 79. There we go. But really, if it's 7, we just round it to like 4, like that, right? Perfect. Amazing. All right, shall we apply it a couple more times? We got 2 more. 2 more. All right, so I got another rational expression. Where does that rational expression not work?
X plus 2 plus
On 2, yes. I knew what you meant. Yes, at 2. Is 2 on our interval? No, so this is going to be continuous on our interval, so we're good. So then we just find our endpoints. So f of -1, that's going to be -1 over -3, which is a third. And then we're going to plug in 1, which is going to be 1 over -1, or just -1. Okay, so there's our endpoints. Is f of c equaling -1/2 between there? Yes, it is. So IVT will work. Yes, IVT. So then we can go ahead and actually like work out what this thing is. So it's going to be c. Actually, let's start with the -1/2. So we know that -1/2 is going to be equal to some value of c over c minus 2. And at that point, I can't really solve this if I've got like rational expressions. So I'm going to cross multiply, which really just means I'm going to eliminate my fractions here. So I'm going to get -c plus 2 equals 2c. Y'all okay with how I got that or not so much? So this is -1 times c minus 2, which means I flip both signs there. Okay. Then I'm going to put the c on the same side. So I'm going to get 2 equals 3c. And so finally, c is going to be equal to 2/3. So this thing will be equal to -1/2 when c is 2/3. That's what it tells us. Okay? All right, the next one's longer. Are you ready? Because now we're going to do some exponentials. I mean, I like exponentials. So the first thing is, if it's an exponential, what do we know? It's defined everywhere, all over the place. So we don't need to worry about that. So it's definitely continuous. So let's just go ahead and find our endpoints. So f of 3 is going to be -1/2 to the power of -3 plus 3 minus 2. Okay, so -1/2 to the power of 0 is 1, but then times negative. So it's -1 minus 2, or -3. So if I plug this in, what is -3 plus 3? 1/2 to the 0 is? Yeah, it's 1, which is then times -1. So -1 minus 2.
Sir, at first you said that because it's something we already know that it's continuous. Can you repeat that? I didn't understand that part.
It's an exponential function. Exponential functions are defined everywhere, so it's continuous everywhere. All right, so f of 5. Now I've got -1/2 to the -5 plus 3 minus 2. Let's work this one out a little bit here. -1/2 to the Negative 2, that's the same as negative 2. Right?
Okay.
Okay. So it's this, right? Negative 1/2 to the negative 2. What's 1/2 to the negative 2, guys? Well, it's technically 2. And then I multiplied it by the negative that's out front. So in other words, negative 4. Nope, that's wrong. See, now you guys made me redo it. I did it wrong there. Negative 2 squared minus 2. There we go. So negative 4 minus 2, which means it's negative 6. Because it was, remember it was squared?
But why?
I originally erased it. So this here, this step, this is the same as negative 1/2 to the negative 2 minus 2. So that this here, this step becomes 2 squared, right? Because the negative, to get rid of the negative, we cross the line, flip the sign, turn 1/2 into 2, and then it's still squared. We just flip the negative 2 exponent into positive 2. All right. So now negative 4 is between negative 3 and negative 6, so IVT works. So then we need to actually work it out. So we've got that negative 4 is going to be equal to negative 1/2 negative c plus 3 minus 2. Copying out the equation. Let's start solving for that c there. So add 2 to both sides. I'm going to get negative 2 equals negative 1/2. Sure.
No, like that. I was watching the videos yesterday trying to get caught up, and I was like,
And you couldn't do it.
to any of your conclusions?
Well, but it's a video, so you can always like pause it, slow it down, watch it 5 times.
I rewatch it and I'm like, oh. Because it's just like, well, we get this because like we get this. What's the rule here?
I think the problem is that you guys need to refresh your algebra. It's usually what it is. For instance, this one, how am I going to solve this? There's 2 ways for me to solve this. What can I do?
You need to like put the same basis so you don't know it.
That's the easiest way, yep. So let's get the same base. So 2, I want 2 to be a half. So I'm going to write this one over here instead. And actually, let's get rid of these negatives, because that's kind of annoying, right? Let's just divide both by negative 1. Because if we do that, we don't have to deal with them anymore. So then we got 2 equals 1/2 negative c plus 3. Now I can make 2 look like a half real easy. Because it's 1/2 to the negative 1. Right? We just did that. Remember we just did that earlier? The way, right? Up here, right? Remember? We had negative 1/2 to the negative 2 was really just 2 squared. Okay, so we're doing the same thing, right? 2 is really just 1/2 to the negative 1.
Or can we just do it 4 over 2?
No.
No, but it's the same thing. Easier.
4 over 2?
Yeah, 4.5. Por eso es que es un 2.
But how does that help you here? I need the same base, guys, because if I have the same base, I can drop the base.
Exactly. 4 over 2 is 2, and it also has the same base.
But it doesn't work that way. Yeah, it doesn't work that way. You need to match it with the one that has the complicated exponent.
It has to be the same thing.
As the one that's got the
entire
complicated.
fraction, not just
I mean, I could change this side, but if
Yes.
I'm changing this side, I need to change this much more complicated exponent. So I wouldn't recommend it. More likely that you make a small mistake. It's possible. It's algebraically true. I don't recommend it. Okay?
So it's like you cancel the 1/2.
I don't really cancel them. I'm just saying, hey, they're unimportant because if it's 1/2 to the power of something equals 1/2 to the power of something, those exponents have to be equal. Right? So then I make these equal. I'm going to add c and add 1. And so c is equal to 4. Let's go up here again. All right, so if I wanted to, what's the other way I could solve this?
In the last part, why did you add c instead of like with the 3 to the other side?
I don't know, because I'd have to move them over and divide by negative 1. It's 2 steps either way. Doesn't matter which way I do it. Just 2 steps.
Why did you hate because you
Military history and mathematics.
know that kind of
That's true.
Oh my god.
Yeah.
That sounds like my nightmare career. Yeah, that's like the
I
things
love
would
military
never
history
do.
and math.
Those are such weird majors together.
Yeah, well, fair enough. But I did it. I still did it.
Sir,
Yeah.
how did you go in that equation that 2 equals and the other part? That 2
Entendí todo, no, la última.
you didn't understand the question?
I did. I did. Negative 4 plus 2 is negative 2. Then I divided by negative 1 and got 2. I did. So, guys, let's go over here because there's another way to solve it, and I wanted to make sure you know how. Sometimes. Thank you. Amelia, you're not my favorite. You and Jack and Nico. Okay, and Emilio. All right, for real, guys, I want you to pay attention because I'd rather you do it on an easy one like this where you could have done it the other way, the easier way. Because if you have 2.5, that's easy to change the base. Pedro, thank you. Okay? It's not always going to be the case. So what's the other way that I deal with this when I have an exponent that is a variable? Logarithm. So what I'm going to do is I'm going to take the natural logarithm of both sides here, the ln of 2. And if I take the natural logarithm of 1/2 to the power of a bunch of junk, what happens to the exponent in logarithms? It comes down in front. So I get that, right?
Why not natural logarithm?
I just like natural logarithm. I don't know. Okay,
Can't we just do log base 10?
if you want to.
Pero,
I just like natural logarithm, all right?
that works.
Because sometimes it cancels out things nicely.
But
There's no reason.
I don't think any of us properly understand.
That comes down in front. So ln of 2.
We learned logarithms like in classes.
Yeah.
And never practiced it again.
Like I said, you guys have an algebra problem, not a calculus problem.
We have a pre.
Then I'm going to divide by ln of 1/2. So then, ln of 2 over the ln of 1/2 equals negative c plus 3. So I'm going to subtract 3.
Excuse me. Mister, I'm right. No. Can you read this class had been so good until no, this class has been horrible. Except for last class. 1.6, that is my favorite. Like if you give me a test on 1.6, it's the only one I can confidently say I will fail. Maybe 1.1.
Guys, I understand that logarithms are hard for you, and I'm sorry for that. You can come see me some other time. This isn't the class for you guys to do it. That's Algebra 2 or Pre-Calc, okay? So I understand that this is a little bit hard for you. I don't care if you write logarithm or natural logarithm, you're going to get the same answer here, okay? Because at this point here, these things, ln of 2 over ln of 1/2, simplifies down to simply be negative 1. I don't care if you don't understand how, put it in your calculator, okay? So this is going to be negative 1 minus 3. So you got negative 4 equals negative c, or 4 equals c. Either way, I get the same answer. Is this way easier?
Yes.
God, no. God, no.
It's like
But what happens if I don't have two things that I can easily rewrite to have the same base? Then I have to use logarithms.
I think
Okay.
are we going to be able to use calculators for everything in this class?
God, no.
No,
You
but
can,
like
you,
with this.
guys,
Can you wait
you can
until
use calculators for about half of what we do in this class.
for like for example, if we
Hang on.
have
Let me end the video and then we can do it. So, hopefully those of you guys watching didn't have as much trouble with the logarithms. Good luck.